In this video, I'm going to be showing you how to implement a Quake-like movement system in Unity 3D. It'll handle collisions, air strafing, bunny hopping, and more. Since I'll be doing this from scratch, I'll be using the high-definition 3D sample template for the project, just so I have an environment to test the movement in. I'm going to go ahead and start removing a lot of the starter content with this project, as we're not going to need it. Before we start creating the Quake character controller, we're going to have to define a new layer for the character. This layer will only contain the character in it. Doing this will make it easier to filter out unnecessary collision checks with our character. As a personal preference, I like to put my character layer on user layer 3. You can put it wherever you would like. I highly recommend naming your mask something clear like character or player. Since this project has a lot of invisible volumes and triggers, I'm going to be going through and verifying that each one of those objects are on a layer which will not interfere with the character controller. It doesn't matter which layer you put them on, as long as that layer also does not have any collidable objects within it. If you have any triggers or volumes in your scene, I recommend putting them onto a common layer like I'm doing. Otherwise, you might encounter other issues like your character controller floating way above the ground. Now that the project is properly set up, we can go ahead and start creating the character controller. To begin, download the repository in the link in the description. After it's downloaded, unzip the folder and drag the Quake character controller.cs file into the Unity assets directory. Once it's imported, feel free to browse through the Quake character controller.cs file. I left some comments above certain methods explaining what their purpose is, as well as some handy information about the Quake movement system. Let's now create our character body and set up the Quake character controller component. Begin by creating an empty component and calling it Quake character controller. I'm going to go ahead and reposition this game object. Feel free to position it wherever you would like in your level. We can now attach a character controller component to our Quake character controller. Feel free to adjust the radius and height of your character controller. For me, I'm going to use 3 as the height and keep the radius as the same. We can now attach our Quake character controller component. This component is responsible for managing the movement and velocity of our Quake character controller, as well as the collision. There's one very crucial property we need to change in the Quake character controller. That property being the ground mask. Ground mask is used to tell the controller what is collidable with the controller and what is not. Only select layers containing objects with collision. I'll be selecting default and transparent FX, as those layers contain all my collidable objects in them. Let's now create the player camera. Create an empty game object instead of our character controller and rename it to player camera. I'm going to go ahead now and reposition this game object to about where the player's head will be at. We can now create a new camera game object inside of our player camera game object. This is what the player is going to be seeing out of. If you launch the game, you'll realize that you can't control or even move your camera around. This is because the Quake character controller component acts as a framework, and we have to write additional code to describe how and where we want to move. Let's start by attaching a new script to our character controller. We're going to call this movement controller, and it's going to be responsible for telling our Quake character controller when and where and how to move. Now open it up in your IDE of choice. I'm going to start by removing the 2 default methods created in the monoBehavior class. We are then going to need to include the Quake LR namespace, as this is what holds the Quake character controller class. We can start by defining a Quake character controller private member field. We're going to call it m_Quake character controller, and this field is going to be responsible for referencing our Quake character controller component on our game object. Next, we need to assign m_Quake character controller. Create an awake method and assign m_Quake character controller using getComponent. Next, define an update method. This method will be used to process inputs as well as tick our Quake character controller. Let's now read our horizontal and vertical input requests. I'm going to be using the legacy input system, but feel free to use your own input system. If you're going to be using the legacy input system, do not use getAxis. Instead, use getAxis raw, as getAxis will interfere with the acceleration of the character controller. We are now going to create a vector 3 called move direction. This represents a character's desired movement direction in world space. It is very important that we normalize this vector. Otherwise, if the player holds down one forward movement key and one right movement key, they will move faster than intended as the vector's magnitude will no longer be equal to 1. We are now going to call the move method inside of our m_quake character controller. We'll be passing the move direction in as a parameter. If you have previously worked with Unity's character controller, you will notice that we are not multiplying by delta time. This is because the move method doesn't actually move the controller. Instead, the move method acts as a setter function. Inside the Quake character controller component is a wish move direction property. This wish move direction property will be set via the move function. The last step is to tell the Quake character controller to do a physics update. We can do this by calling the controller think method and passing in delta time as the first parameter. This method is responsible for calculating and moving the controller. We can now playtest the game. Because my project was configured for the modern input system, the controller is failing to process inputs because I was using the legacy input system. If you're also using the legacy input system and encounter this issue, you can go to your project settings, then go to player, then open up the other settings panel, and change the allow input handling to input manager old. You're going to be asked to restart your editor. Agree and restart your editor. Once your editor has been restarted, you can go and playtest the project. You will now be able to move around your controller. However, you won't be able to look around or jump. Let's start off by implementing jumping. Go back into your movementcontroller.cs file. Create an if statement and check if the player pressed the spacebar that frame. If the condition is met, call the try_jump method on the m_quake character controller. The reason we're calling try_jump instead of jump is because try_jump has edge cases to prevent jumping when the controller physically can't. For instance, if we use jump, the player will be able to spam space and continuously launch the character in the air. We can now go back to the editor and playtest our changes. You can see every time I jump, the character doesn't fall back to the ground. This is because I forgot to put the Quake character controller on the character layer. Let's now implement the ability to look around via the mouse. Attach a new script to the player camera called player camera controller. In your player camera controller.cs file, begin by removing the default methods. Create a private transform field called owner transform. We are going to need to assign this transform in the editor, so we'll make it a serialized field. We will then create an update method and an awake method. Inside of the awake method, we'll be setting our cursor lock mode to locked. We are now going to define a float called m_camera pitch. We are assigning the camera pitch to a variable as it will make it easier to clamp the pitch. Then let's read and process our mouse inputs. We can then offset our camera pitch variable by our mouse Y. But then we will clamp the resultant angle between -80 degrees and +80 degrees. We can then call rotate on our owner transform, passing in vector3.up as we want to rotate on the yaw axis, then passing in mouse x as that's how much we want to rotate by. We can then set the local rotation of our player camera. We can create a quaternion using quaternion.euler. The pitch of the quaternion will be m_camera pitch while the yaw and roll remain at 0. Back in the editor, go to the player camera. Assign our Quake character controller to the owner transform. We should be good to play. You can now freely look around with the mouse, as well as bunny hop and air strafe. Hopefully this guide helped you. You should have a fully controllable Quake movement system in your game now. Feel free to experiment with a lot of the Quake character controller settings as well as read the code.